So now let's take a look at how we are going to, given a polynomial like this, last week they were typically given to us in a factored form. If it's given to us all the way expanded out, how do we get to the point that we can find all the zeros and graph it? Well, the first thing we're going to want to do is fill in the information we can. Let's start with what is the maximum number of real zeros. That is the same as the exponent, or the degree of the polynomial. Since this is degree 4, this has a maximum number of zeros of 4. What's the maximum number of turning points? The maximum number of turning points would be 3, because that's one less than the degree. What is the end behavior? Since this is even degree, and the leading coefficient right here is positive, the end behavior is going to look like this, right? So this is going to have those arrows pointed up. What is the y-intercept? To determine that, we're going to plug in a 0 for x, and you can see we're going to get 0 plus 0 minus 0 minus 0 plus 24. So the y-intercept is 0, 24. Now, list all of the possible zeros. How we find the list of possible zeros is by looking at the coefficient in front of the term and then looking at the constant term. So really quickly, we're going to call the term at the end, the constant term, p, and we're going to call the coefficient up front, q. So p is equal to 24, right? And q is going to be equal to 1. Now we're going to want to write all of the factors of 24. So all of the factors of 24 are plus or minus 24, plus or minus 12, plus or minus 8, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, and plus or minus 1. And then all of the factors of 1 are just plus or minus 1. Now the list of possible zeros is all combinations of p and q divided. So the list of all possible zeros is going to be p divided by q. So plus or minus 24 over 1, plus or minus 12 over 1. We know these are all going to be over 1, so really it is, in this case, going to be a list of all of these zeros. So these are all of the possible zeros. Plus or minus 24, plus or minus 12, plus or minus 8, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, and plus or minus 1. Now, before we had technology, what the next step we would need to do is plug all of these numbers in to see if they work out to be a 0. But thankfully, we have the use of graphic calculator technology that what we're going to do now is we're going to graph this and we're going to find a 0. So let's go ahead, and I'm going to use Desmos because I don't have a graphic calculator on my computer, but you can do this using the TI-83 graphic calculator as well. So we are just putting this function in, minus 2x plus 24. All right, so what I'm going to do here is I'm going to identify, I can see right now there are a couple of zeros. These ones look non-rational. I know this is a 4th degree polynomial, so there are a minimum of 4 zeros. I've actually found 2 of them right away. So I know I have zeros at -4 and +3. I'm going to mark those right now. I know we have zeros at -4 and +3. I'm not sure what those other ones are. They seemed irrational. Those were not whole numbers. Can you see that -4 is in the list right here and +3 is in the list right here? So in that list of possible zeros, these ones are in there. Now, the reason we need synthetic division, the reason that we talked about the previous, is what I'm going to do is I'm going to take this polynomial, x to the fourth plus x cubed minus 14x squared minus 2. Let me just write it. We're going to divide this up. We are going to take those zeros and we are going to break this up. So, we're going to put our coefficients here, 1x to the fourth, 1x cubed, minus 14x squared, minus 2x, plus 24. Whoops, shouldn't have an x there. It should just be the coefficient. So let's get rid of that x term right there. So it's just minus 2 there. And then we're going to put, let's divide by negative 4 first. Since we know this is a 0, that is the number that goes in the box. That's different than the last example. We know in factored form it would look like x plus 4, but it's going to be minus 4 for the 0. Now, what we're going to do is we're going to bring our first number down. 1 times negative 4 is negative 4. 1 plus negative 4 is negative 3. Then we multiply. Negative 4 times negative 3 is positive 12. Then we add down. Negative 14 plus 12 is negative 2. Then we multiply. Negative 4 times negative 2 is positive 8. Then we add down. Negative 2 plus 8 is 6. Then we multiply one last time. Negative 4 times 6 is negative 24. Positive 24 minus 24, this gives you a 0, and I want you to key in right here because you should always get a remainder of 0 if you use technology to find these zeros. Since we know that we put this in correctly and that we found that that was a 0, it should give us a remainder of 0. Now, why did we do that? We did that because what this actually did for us is if I take this 0, I have an x plus 4 as a factor, and then this stuff right here are the coefficients of what we call the quotient. This was a 4th degree polynomial. It has now become a cubic polynomial because I factored out or divided out the x plus 4. So this is the x cubed term, this is the x squared term, this is the x term, and this is our constant number. So what we have is we've gone from a 4th degree to now we have x cubed minus 3x squared minus 2x plus 6. That was helpful for us because we had no way to be able to factor that before. Now, I want to get this to a squared term because I know how to work with or factor a squared term. Luckily, I've got another 0 right here. So now what I'm going to do is we're going to take this one. I know there's a factor of 3 in there because I found it at the very beginning. I didn't factor it out yet. And we're going to do polynomial, or we're going to do synthetic division with 3. The coefficient in front of x cubed is 1. The coefficient in front of x squared is negative 3. The coefficient in front of x is negative 2. And then our constant term is 6. Let's do that synthetic division process again. We're going to bring the 1 down. 3 times 1 is 3. Negative 3 times 3 is 0. 3 times 0 is 0. Negative 2 plus 0 is negative 2. 3 times negative 2 is negative 6. And you can see again we get a remainder of 0. That is a good thing because I knew that that 3 was a factor or was a 0 of the polynomial. So let's bring our x minus 4 down. Our original polynomial had an x plus 4. I also took out an x minus 3. Again, remember if it has a 0 of 3, it's x minus 3 in the factors. And then I have x squared plus 0x minus 2. This is great for me because now what I can do is I can solve this one right here. Sometimes I might need a quadratic formula or just factor it, but with this one, since it's just an x squared term, I'm just going to set it equal to 0. Add 2 to both sides. I get x squared is equal to 2. Take the square root, and this is where it's really important. I see a lot of students miss. Please put a plus or minus in front of the 2, or of the right side when you take the square root. And we get x is equal to square root of 2 and negative square root of 2. So our zeros This allowed us to get this completely factored into x plus 4, x minus 3, x plus radical 2, and x minus radical 2. Notice that our square root ones came in pairs. That's something we're going to be talking about in the next video. So we know our zeros are negative 4, 3, radical 2, and negative radical 2. And they all have multiplicity 1, right? These have multiplicity 1, which means they're all going to cross, right? So going back up, I'm going to take a look and we're going to put our pieces together. We know that this has an end behavior that's opening upwards. We know it has a y-intercept of 0.24 that's somewhere up here. We know that this has the zeros at negative 4. Let me use a different color. It has a 0 at negative 4. It also has a 0 at 3. It does not like me drawing dots. It also has a 0 at radical 2, which is something like 1.41. And then it has one at negative radical 2, which is negative 1.41. So if I was instructed to draw a rough sketch of this, I would start. We know it crosses through, and then goes way up here, and then goes way down, and then passes through and matches up with my end behavior. Again, not a very nice picture, but I am just using the pieces I have to be able to draw that graph.